Chapter 3.2 Equivalent Ratios and Proportions. Now, as we have already previously studied in the first chapter of the year, ratios compare quantities that are measured in the same units. So let's start off with a quick example. It says, write as a ratio. The question says, if we have 60 out of 100 people who drive to work, well then, this must imply that 40 out of 100 people do not drive to work. Therefore, if we were to write this as a ratio, then we could simply write this as 60 to 40, where the 60 represents the people who do drive, and the 40, of course, represent the people who do not drive. Pretty simple. In terms of the idea of proportions, recall that ratios can be expressed as fractions. However, the denominator of the fraction may not always represent the total. So here's an example. I have a 1 to 4 ratio. I could simply write that as 1 over 4 in fractional form. However, in this situation, the 4 on the denominator may not actually, and is in fact not actually, the total. Now, if two ratios are equal, then what we suggest is that they are said to be in proportion. A 2 to 3 ratio is really the same as a 4 to 6 ratio. So in fractional form, we can write it as 2 over 3 equals 4 over 6. Now this statement here that we've written, or this equation that we've written, is what we call a proportion. Well, this is going to be very important for the next part. So this idea here is known as the proportion rule. So if we set things up in this fashion, where it says A over B equals C over D, in other words, we have a fraction equals a fraction, then what we can say is that A times D, that dot here represents times, is equal to B times C, and therefore the fractions C over D and A over B are what we call proportional. Now, like fractions, ratios can also be reduced to lowest terms. So here's an example. If we have a 16 to 12 ratio, this can be reduced to 4 to 3, since both values divide by a common number, in this case 4. If we have another example here, a 15 to 5 to 25 ratio, well, if we look at all those numbers, they all divide by 5, so therefore 15 to 5 to 25 is equivalent to 3 to 1 to 5 ratio. Now, one thing to note is that when we do write our ratios into lowest terms, a properly written ratio should have whole numbers as all the digits, no decimals, no fractions. So the other thing to remember is that there should not be any units written to any of those numbers as well. That seems to be a common mistake that I see on a lot of tests and quizzes, that students write down the units when in fact there shouldn't be any at all. Now, how do we go and calculate proportions? So here's an example. The example is that we have 8 over 5 is equal to x over 4. Now, there's a few different ways to go about doing these questions, but at this point in time, I'm going to teach you a method. And this method is known as the idea of cross multiplication. Now, we're going to revisit the idea of cross multiplication a little bit later when we get into the idea of algebra, but for now, the idea is that if you have a fraction equaling another fraction, then you can simply use this idea of cross multiplication. So what does this mean? In the idea of cross multiplication, what you do is you take the denominator here and multiply to the numerator of the other fraction. You take the numerator here and multiply to the denominator of the other fraction. So therefore, if you can see, what we then have is the following. We have 8 times 4 is therefore equal to 5 times x. So I got 8 times 4 is equal to 5 times x. Okay. So if I work this out then, 8 times 4 is equal to 32. 5 times x is equal to 5x. Now we'll learn a little bit more about this process when we get to the idea of algebra. But at this point, what you're going to do is say to yourself, well, the x is being multiplied by 5, so I'm going to then divide by 5. And when I divide one side by 5, we'll divide the other side by 5 as well. That's a thing you're going to remember for when we get to the algebra section. So therefore, we're going to be left with x being equal to 32 over 5. Now in this final example, we have a word problem. It says the amount of penicillin that a child should take is proportional to their weight. If a 21 kilogram child should take 120 milligrams of penicillin, then how much should a 28 kilogram child take? Well, the first thing you want to do with a proportion type of question like this is to set up your proportions in the form that we looked at before, a over b equals c over d. So here we have a 21 kilogram child should take 120 milligrams. So we're going to set that up like so. 21 kilograms over 120 milligrams is equal then to the 28 kilogram over x milligrams. So x here is what we want to determine, which is the amount that the 28 kilogram child should take. So now all we have to do is solve this equation, and recall that the process we're going to take is the idea of cross multiplication. So I'm going to multiply the 120 to 28 and the 21 to the x. So I'll have 21 times x, which is 21x. I'll have 120 times 28, like so. So I'll multiply my calculator, 120 times 28. So I get 3,360 is equal then to 21x. Now, the next thing I do is I want to divide by 21, because x is being multiplied by 21, so I want to divide, which is the opposite operation to multiplication. We'll talk a little bit more about the idea of opposite operations when we get to algebra. So we're going to be left with x on the left side. 3,360 divided by 21 works out to 160. And of course, don't forget your units, in this case milligrams. So that ends this chapter. So hopefully this video has helped you to understand the idea of equivalent ratios and proportions.